Untitled Institute of Engineering and Technology. Today we are going to discuss few more topics of Laplace transform. So let's begin with the first topic, that is Laplace transform of integrals. So if Laplace transform of ft is equal to f of s, then Laplace transform of integration 0 to t f of t dt is what? Fs upon s. Okay, so what we have to do, we have to just divide it by s. Okay, whenever we have to find integration of 0 to t ft dt, right? Now let's see its proof. So Laplace transform of, we know this formula, Laplace transform of ft is what? Integration 0 to infinite e raised to minus st ft dt, correct? Now in place of ft, here we have integration 0 to t ft dt. Okay, so here in place of ft we have integration 0 to t ft dt. Okay, now we will integrate it by parts. Okay, so now we know this formula, that is u dot p dx is equal to u integration p dx minus du by dx integration v dx and this whole dx, correct? This is the formula. Now what we have to do, this u as it is. Okay, so this is u and this is v. Okay, so this u as it is. Now integration of v, so e raised to minus st upon minus s, we are integrating with respect to t, limits are 0 to infinite, minus integration 0 to infinite. Okay, now again we have to find this du by dx, okay, and integration v dx. So this integration v dx is e raised to minus st upon s, okay, and d by dt of this integration. Okay, now what we have to do here, now if you will substitute the upper limit, that is e raised to minus infinite, it will become 0, okay, and on substituting 0 here it will become 0, so this portion is gone. Okay, we have only this portion, that is integration 0 to infinite minus minus plus e raised to minus st upon s ft dt. Okay, this 2 will get cancelled, so we have only ft dt, right? Now so we know this s we will take outside the integration, and integration 0 to infinite e raised to minus ft dt is what? Laplace transform of ft, and we can write it this as f of s. Okay, so we will write this as fs upon s. So Laplace transform of integration 0 to t ft dt is what? Fs upon s. Now let's solve an example. Find Laplace transform of integration 0 to t e raised to t sin t upon t dt. Okay, so firstly what we'll do, first we'll find the Laplace transform of sin t, that is 1 upon s square plus 1. Now we'll find this sin t upon t first. Okay, so this is integration s to infinite fs ds. Okay, and this is the fs. So here we have 1 upon s square plus 1 ds. Okay, now the integration is what? Tan inverse s. Okay, so this is tan inverse s and the limits are s to infinite. Tan inverse infinite, that is pi by 2. Okay, so here we have pi by 2 minus tan inverse s. Now we know pi by 2 minus tan inverse s is what? Cot inverse s. Okay, now we will apply e raised to t to this term, that is e raised to t sin t upon t. Okay, so whenever we are applying e raised to t, what we have to do, first shifting theorem. Now the coefficient of t is 1, so in place of s we have to write s minus 1. Okay, so here we have cot inverse s, so we will write cot inverse s minus 1. So we have simplified up to this. Now we will apply the integration. So Laplace transform of integration 0 to t e raised to t sin t upon t dt. Okay, so whenever we are applying this integration, we have this formula, that is fs upon s. Okay, and now the fs is what? Cot inverse s minus 1. So your final answer is cot inverse s minus 1 upon s. Okay, now let's solve one more example. Double integration 0 to t sin 80 dt. Okay, so firstly we'll find Laplace transform of sin 80. Okay, so this is a upon s square plus a square. Now first apply one time integration, that is 0 to t sin 80 dt. Okay, so whenever we are applying the integration, we have to divide it by s. So here we have c. Okay, so just divide it by s. So here we will get s square plus a square. Okay, now again we need one more integration. So 0 to t sin 80 dt, correct? So we have to divide it by s. So this is a upon s square plus a square. Okay, so whenever integration is present, we have to just divide it by s, so you will get the answer. Okay, now let's study one more topic, that is Laplace transform of periodic function. So firstly, let's understand what is periodic function. A function f of t is said to be periodic function if there exists a constant p which is a greater than 0 such that f of t plus p is equal to f of t for all value of t. Okay, so if we are getting this type of result, okay, then we can say that this function is a periodic function with period p. Okay, now if f of t is a piecewise continuous periodic function with period p, then Laplace transform of f of t is what? 1 upon 1 minus e raised to minus ps integration 0 to infinite e raised to minus st ft dt. So whenever in the question, if a periodic function is given, we will use this formula to find the Laplace transform. Okay, now let's discuss its proof. Firstly, we know this formula, that is Laplace transform of ft is what? Integration 0 to infinite e raised to minus st ft dt. Okay, now we will just split this integration in two portions. Okay, that is from 0 to p and p to infinite, right? Now what we will do in this second integration, in place of t we will write x plus p. Okay, so just dt, so dt will be what? Dx, right? Now as we are changing the variable, we will change the limit also. Okay, so when t is equal to p, what you will get? Now in place of t here, substitute p. Okay, so what you will get? This p will get cancelled, so x is equal to 0. Okay, and when t is equals to infinite, you will get x is equal to infinite. Okay, now substitute all the values in this second integration. Okay, so what you will get? Integration 0 to infinite e raised to minus s, here we will get x plus p and f of x plus p dx, and the limit is 0 to infinite. This term will remain as it is. Okay, now again this integration as it is. Now e raised to minus s and p we will take it outside. Okay, because here we have integration in terms of x. Integration 0 to infinite e raised to minus sx into fx dx. Okay, now what we are doing over here, we are just changing the variable. So in place of x, I have written just t. Okay, so all other thing is same. In place of x, just I have written t. So we have here e raised to minus sp 0 to infinite e raised to minus st ft dt. Okay, now this is Laplace transform of ft, right? So this is Laplace transform of ft. Now what we will do, we will bring this over here. Okay, so we have already Laplace transform of ft over this side. We will take it common. So Laplace transform of ft, take it common. Okay, so what you will get over here? 1 minus e raised to minus sp is equal to what? Integration 0 to p e raised to minus st ft dt. Right, bring this in the denominator. So here we have 1 upon 1 minus e raised to minus ps integration 0 to p e raised to minus st ft dt. Right, so this is the formula we have to use when a periodic function is given. Okay, now let's solve one example. Find Laplace transform of ft. Function is given in two parts, that is sin omega t between 0 to pi upon omega and 0 between this interval. Okay, and it is given that f of t is equal to f of t plus 2 pi upon omega. So this type of condition is given in the question. Okay, so this is a periodic function condition. Now from this we will write the period. So what is the period p? It is 2 pi upon omega. Now, the formula to find Laplace transform of ft, where the function is periodic function, is 1 upon 1 minus e raised to minus ps integration 0 to p e raised to minus st ft dt. Okay, this is the formula. Now, what we have to do, we have to substitute the value and then we have to integrate it. So this is 1 upon 1 minus e raised to, here p is what? 2 pi omega. Okay, so minus 2 pi omega s. Okay, and here integration 0 to 2 pi omega, right, e raised to minus st and ft dt. So here interval is given in 0 to 2 pi omega, 0 to 2 pi upon omega. Okay, so what we will do, we'll split the integration in two parts, that is 0 to pi upon omega and pi upon omega to 2 pi upon omega. Now as you can see in this interval the answer is 0. Okay, so no need to write this, we will write only this interval. Okay, so here we have 1 upon 1 minus e raised to minus 2 pi omega s integration 0 to pi upon omega, okay, e raised to minus st, and function is what here in this interval, sine omega t dt. Okay, now to integrate this, okay, so we will use this formula, this integration e raised to ax sine bx formula. Okay, this we know, this e raised to ax upon a square plus b square. Okay, here a sine bx minus b cos bx. Okay, this is the formula, so we will use this formula to integrate this portion. So 1 upon 1 minus e raised to minus 2 pi omega as it is. Okay, now here e raised to minus st upon s square plus omega square. Okay, from here we will get minus s sine omega t. Okay, I am writing over here minus omega cos omega t, and limit is from 0 to pi upon omega. Right, now to substitute the limit, what we will do, in place of t we have to write firstly pi upon omega. Okay, so what you will get, upper limit e raised to minus s pi upon omega upon s square plus omega square. Okay, now if you will substitute pi upon omega over here, the omega will get cancelled and sine pi is 0. Okay, so this term is gone. If you will substitute over here, you will get cos pi. Okay, and cos pi is minus 1, so minus minus it will become plus, and we have only omega as the upper limit. Okay, now we'll substitute the lower limit. Okay, so this is the answer for upper limit minus, now substitute lower limit, so 0. So e raised to 0 is 1 and upon s square plus omega square. Okay, now sine 0 is 0, cos 0 is 1, so here we have minus omega. These are the limits. Now just substitute, simplify this, so we'll get 1 upon 1 minus e raised to minus 2 pi s upon omega. Okay, and from here we'll get e raised to minus s pi upon omega upon s square plus omega square into omega, this minus minus plus omega upon s square plus omega square. Right, this is the simplification. Now in the next step, what we will do, we will take this omega upon s square plus omega square common. Okay, so what you will get, e raised omega upon s square plus omega square common. Okay, so what we will get over here, e raised to here minus s pi upon omega, e raised to minus s pi upon omega, and from here what you will get, plus 1. Okay, so plus 1, and upon in denominator what we have, this 1 minus e raised to 1 minus e raised to minus 2s pi upon omega. Okay, now further we can simplify this term by using this formula, that is a minus b, a plus b is what, a square minus b square. Okay, so this omega upon s square plus omega square as it is, this 1 plus e raised to minus s pi upon omega as it is. Okay, and this we can write as e raised to minus s pi upon omega. Okay, and here 1 plus e raised to minus s pi upon omega. So this is a minus b, a plus b, so it will give you a square minus b square, so you will get this term. Okay, now this two term will get cancelled. Okay, and what remains is omega upon s square plus omega square 1 minus e raised to minus s pi upon omega. Okay, so this is your final answer. So I hope you have understood throughout the session. Thank you for watching.